welcome back to a new video here on the Lötwig Fusel channel in my Boundless 2D game engine, video series. Could you name something like this tutorial? I don't think so. It's more or less a project, right? So what we have done in the last videos, we've worked a bit on inversion of control, and maybe we also worked on breaking IntelliSense. I don't know why it just worked, and now it's broken. Okay, there it is back. Sorry for that interruption. But yeah, basically what we have done is we have implemented inversion of control. So basically what we implemented is IOC registrations on an IOC container. That one container is IOC registrations. It's not like really a container, but it's like the registrations that a container for IOC registrations. And then we had an IOC stack, and on an IOC stack you can kind of like instantiate inversion of control objects. They're automatically going to get destructed when the stack is cleared and fancy things like that. So the general idea is that our code is going to be split up in modules and APIs, and every like module implements a certain sets of APIs, and the APIs kind of like define the functionality of the engine. So rather than actually creating a dummy implementation, I'm going to ask for the dummy interface that, depending on which modules are loaded and compiled, could be like different implementations. For example, there could be a module implementing Vulkan, there could be a module implementing the 3D12, and if you're on Windows, both of these modules are compiled in, and you can select both of these implementations by providing a additional positional argument, like the name of the implementation that you want to have. And on Linux, of course, DirectX 12 is not going to work. So basically, you have in the future going to have a configuration file of the engine, and in there is going to be a renderer name. And on Windows, you can select the 3D12 and Vulkan, and on Linux only Vulkan and something like that. And it's basically just a way of decoupling our system and initializing our system. This is all based on singletons, and it's rather a amazing concept, and I think we're going to get quite far with it. We also implemented it in a very limited way so that it stays simple. If we need more features, we can add them later on. Alright, so now what I want to do today is I want to go into how modules are loaded. Currently you can see that I'm implementing the module loading manually in my main. So in general, let's maybe clear all of that code that was just like testing. This is like the default one. I don't know why I still have the old testing code in here, but basically this was kind of like the usage of the code. This is kind of like the context, the stack, and we manually implemented the module loading by instantiating every module and registering every module. This is of course not what we want to do. Why don't we want to do that? Well, because we need to do it conditionally, and it's hard. I want to implement automatic module loading, and I want to implement these by implementing a module manager. So currently you can see that we have the AMSys. This is the core library for module management. We have an iModule and a module description in there that are describing a module, and what I want to implement now is a module manager, like module manager.h. And I think we put the module in the root namespace. Yeah, that's where we put the modules in here. Let's paste the code in here so that we have like a template to start. I don't think that we need these. What we're gonna need is the module interface. Maybe we do need the IOC registrations because we're gonna reference them, but I do need the iModule itself, and then we're gonna have the module manager. This is the class that we want to implement. And this class shall kind of like handle module loading. Now the module manager is going to be a singleton. So basically what I'm going to have is I'm going to have a inline static module manager reference get to get the singleton. It's a static module manager instance, and I want to return the instance. That's how I like to do my singletons. We're gonna have a default constructor, no copying available also for that one, and this is kind of like now our singleton. And now let's actually implement the class. So the class is also gonna have its public and private members, and this is now where things are getting interesting, because now we need to implement the modules. Let's create the matching CPP file, which means that we can get rid of the dummy file, And now we are ready to implement it. So how do I want to store modules? Actually, I haven't really made up my mind how I want to do that. One thing that's for sure is I want to store the module instances. I want to store them in a probably not a shared point. Let's maybe do a unique pointer. That's a good idea. Now, how do I want to store the modules? I think we could get away with a list or a vector, but I'm not really sure. If it's really how I want to do it. I think I more want to do it in like a structured, not a structured, like a key value storage, so that I might can get modules by its name. So let's maybe store them in a unordered map. That would be a good idea. So unordered map, and since we need a key, let's use a string as a key. And let's implement the storage here. So we're going to have a unordered map in here. We're going to map from an std string, which is the module name, to a std unique pointer to a I module. So that's the idea. This is kind of like the modules list that have been loaded, or not loaded, because I think currently, do the modules support loading? They only support registering currently. We might implement module loading in the future as well, so that modules have time to maybe set up their own internal states when they are really loaded and not when the application comes into scope. So if a module has a internal singleton, for example, like if we later on implement like something like window registering and stuff, you could, or like Win API stuff, the module could kind of like have a static init. Even through it's not like it's not meant to be like that. Modules are meant to be kind of stateless. This is kind of like the general idea. However, we might want to give it a bit of a information. Now in the module description, you're going to see that we have a package name, a display name, and a description. The package name is kind of like what I want to have as a key in the unordered map. This is the general idea. All right, so how do I want to implement that? So first of all, I need a method to register a module. So let's add a void register. How do I want to register a module? I think I am just going to do it as a unique pointer here. And actually, I want to move this pointer. So a move constructor for a unique pointer. And then let's call this module. This is the module that we want to use. We should add docs to that, actually. That manages all modules. So that's the idea. So we have the register function in here. Let's say pointer to module instance moved to this class. We could use shared pointers, but I think like a module, it's really meant to be managed by the module manager. Actually, we're probably never going to call this barebound register method at all. We actually are going to later on do it a bit different. But that's not the story. Registers a created module within this container. Yeah, registers a created. Now let's just say registers a created module. Now how do I want to do this? First of all, I want to initialize the module itself, right? We have the module, and I want to call a function on there. Actually, what I want to do is I want to register it to a IRC registrations stack. I am just gonna to IRC registrations container. I'm gonna just register it to the static one that's initialized. And then what I want to do is my modules add, and now I basically want to get the description of the module and get the package name of the module, and then I want to std move the module pointer in here. So that's the idea of the code. We're going to call register on the module itself so that it registers with the current IOC, and then we want to move the ownership of the module into this class. That's kind of like the idea here of the flow of the code. And now the module is kind of like registered in the manager. Now, what I also want to have is I want to have the possibility to iterate over modules and to get a module detail. So module description pointer, get module detail. and I want to get a module detail to a const. Since we are on a map, we need to have it as a std string, sadly. Or could we use find if, but I think it's bad to use find if. But yeah. So get module detail, I want to get this to a package name. So retrieves the details of a module. Just the details of a module by its package name. Package name of the module. Returns pointer to, actually this should be like a const pointer to the descriptor or null. So in case there's something wrong, I wanna get null pointer. And what this allows me to do now is to basically look this up. So it finds, so we could use just a normal iterator equals modules find package name, and then if it not equal modules.end, what I want to do is return package name. Yeah, let's dereference it, or let's do it second dot. Come on, why? Not package name. Yeah, iterator second, and then we want to get the description here from the module, and this is a reference, so it needs to be a pointer in there like that, and otherwise I am just gonna return null pointer here. Now what I also want to do is I want to be able to iterate over the modules, so size t, actually like this actually can be const because we are not modifying anything, so let's make this const, even though like this is a singleton and const correctness is not really a concern here. Yeah, but what I want to implement as well is I want to also implement a size t get module count, so how many modules are inside of the container. Counts the number of registered modules. Module count is the return value. And then inside of here, I want to return a module size to get the number of items in here. And then I also want to have a const module description get module detail, but now instead of the package name I also want to have the index. And actually we maybe should bring these functions together because they do the same thing by its internal index. And maybe we should do a normal map, maybe an ordered map, right? Because like if we're using a normal map, it will stay in the same index, so it's always gonna be asserted that the count is not changing or the index is not changing of a module even if we are appending stuff. So maybe that's the better thing to use. Index of module, and then returns actually, yeah, let's this can point to the descriptor. Never null, only exception. So actually I don't want to return null there, I want to be able to just return exceptions. So let's call it iterator. So the iterator is equal to modules begin, and then we're gonna say plus equal index to kind of like increment the iterator, and this doesn't work. Equals it plus index, should that work? No. Iterator, can we not, does the iterator not specify, like I mean iterator arithmetics are a thing. Can we, since it's a map, we can maybe do a add index? No. Okay, that's interesting. Isn't there a way of getting, of incrementing the iterator at a certain way? cd3 const iterator. std map city string. Like what is let's see. Let's see. Const iterator. What is a const iterator? Tree const iterator. What does this iterator implement? Unchecked. Operator plus plus. I mean plus plus works. Plus plus int works. Minus minus. Equal equal. And we could just implement it the straightforward way, right? Like that. And then we return iterator second get description. And this is like a very bad implemented way, but it should still work. I mean, like, it's not a good idea to always iterate, but it probably, if there would be a method, it would internally do the same thing. So, yeah, I think this is fine, even if it looks a bit ugly, but I think that's okay. Now we only need a shorthand version of the register function, because I basically want to be registered to register any type. So template, type name T, void register. And now I want to register without any details. And basically what this is going to do, this is going to call the actual function here with std make unique. And I want to make T unique. So basically what I want to do is I want to register a new T. And I want to directly do it. We couldn't use a std move to in there. This is how it should be done. And we maybe want to also add arguments, right? Type name args. And then we can say args. And then what we could do here is std forward args dash 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 to basically also unpack the parameter list. I don't think that std forward is already in here because it's like in a header that I never remember. I think utility or something. Was it the utility header? But I am not confident with that. Utility, yeah, it is. Utility, yeah, come on, utility header, and then it is in here. You can see that this looks a bit ugly, but it should work, right? Registers a newly created instance of a module. I'm not quite sure if it can autocast to iModule, but it should be. Type of arguments, type, module, type. We could add type traits in here, like type name equals std enable if t, but for that we need type traits, and then we can do a std is base of. So the base is the I module and this is T, so it basically needs to be of the same type. And then we should be able to call the proper register method on here to kind of like forward the registering. And I also want to have another register function, void register all. Maybe we don't want to have it in here, the register all function. It's probably so. We're gonna have a register all function, but maybe not in the module manager. Alright, so this is basically the boilerplate code that we need for managing the modules, and now we just need to kind of like use that. This module manager, and instead of registering it like that, I basically want to do it like that. So module, so bl2d module manager get, and then we want to register, and what we want to register is we want to register that concrete implementation of that, or not that complete implementation, but like this module. We want to register that module, and this should now, in theory, do it. Let's quickly do a autoref mm for the module manager, just that I have something to work with, and then let's call register, and let's see if this compiles and does its thing. I'm quite sure, maybe it does not even compile, but I can't tell. Because templates and Visual Studio is sometimes a bit of a thing. So if I register, my size goes to 1, and now you could see that there's the BL2D dummy, and you can actually see some stuff on there, and if I would go down, I would see implementations, but I don't see the descriptor because it's not a member, but and that's kind of like the idea. Let's see if the pointer is actually valid. The pointer DMY is actually valid, so all the stack and all the registrations have worked. That's good. So that already seems fine. And now we can continue on with that stuff. Yeah, you can see that we currently need to still register modules manually. I mean, we have now a module manager, but the module manager is not really managing the modules. I mean, it's still managing them, and maybe we should have kind of like an unload function there as well, but we kind of like have access to a module manager, and we could also go in here and also see what's inside of the module manager, right? If we want to have some debugging code, we could do something like for size ci equals 0, I smaller, get module count, I plus plus, and then I could do something like spd log info, and I could go in here and say module that, and then I want to have the package name as well, and then I could do something like get module detail for the index, and then I can say like display name and package name, and then I can quickly like get myself some information about the modules that are loaded. This is kind of like the main purpose why I want to have a manager, so that you can actually see which modules have been loaded, right? If you're taking a look at logs and stuff like that, you want to actually see which modules are registered, and also like the IOC registrations, we should also in the future make these one iteratable as well. But yeah. Now we want to have automatic module registrations. So currently you can see that the module manager is basically just a manager. However, what I want to have is I want to have a function here externally, just a floating function, the BL2D namespace, and this function, the BL2D namespace, is going to be a void register all modules. This is a function. This is just going to float around in the BL2D namespace. But this function is not going to have an implementation. Now, the general idea is that you don't need to go over the module manager, only for like something like iterating, right? If you do stuff like that, you of course need the module manager for that. Maybe we can make it like that so that it doesn't look that ugly. And in general, what I want to do is I just want to, at the start, call pl2d register all modules. But if I'm doing it like that, you're going to see that it's not going to compile, because basically it's not going to find an implementation of this register all modules functions. Now, this is now something where the implementation is getting quite interesting, because I actually want to now have the implementation of the module registrations inside of my dummy package. Now, this seems quite odd. Why do I want to have it in here? Well, because basically this is something that's configured on a per application base. Later on, we might have a IE online services interface, and the IE online services interface depends on if it's a build for Steam, if it's a build for the Microsoft Store, if it's a build for Xbox, and whatever the game might be built, it might be a different module for the IE platform services. However, everything is going to use the interface so that you can use a uniform or implement a uniform game. How is that possible to do? We need to have it inside of the application, so that we have an application that can control which modules are actually loaded. Now, currently, our build system is not very flexible in that. Currently, it's just going to instantiate all modules. But this is something that in the future is going to probably change at a certain point. However, what I want to have is I want to have a way of actually like generating a kind of like module registration file. So how is that going to happen? Well, it's basically going to happen with a template again. So I'm actually going to go into my template and I got to create a new file in here. It's not going to call module. It's going to call load modules.cpp. That's how it's going to be called, load modules. And basically what I'm going to do here is I'm going to do a few things. So first of all, I'm going to have a general include, which is going to be bl2d. Actually, this is just a single CPP file, so I'm going to do it like that. bl2d common msys and then the module manager. This is what we need. And then we're going to have the namespace bl2d. Well, actually, I think we can just do it like that. bl2d load all. It's not IntelliSensing that, but it's called register. Okay. Register all modules. There it is with the IntelliSense. And basically this is gonna implement that one. So how do we do it? Well, actually what we need is we need two sections. I first gonna need module includes. So all of the includes for modules and module registers or module rec calls. This is, let's maybe type this together, module rec calls. Module includes, module rec calls. So the register calls and the includes. This is basically what we need to do. Now what we need to do is we need to generate the includes and we need to generate the rec calls. So how can we generate them? Well, I'm gonna copy that one, that name, and we're gonna go inside of that here. You can see generate module H or CPP on demand. This is the function we call to generate a module header or a module CPP file. And now I'm gonna generate, call the function generate module registers. How did I call this? Load modules. That's not a good name. Register modules. And this is going to be called generate register modules. And this is not going to get anything, right? This is just going to be a empty function. Maybe we're going to add a list here. So modules. Maybe we're going to put in the modules that shall be generated in here, and later on we pass the right ones. So 4 I pairs in 4kv in I pairs of the modules we want to iterate. So basically what I want to build up is I want to build up a new array. It's going to be the local includes. Actually, let's call these ones how do I want to do it? Okay, includes, that's actually okay. We're gonna have includes and we're gonna have register or rec calls to stay at the naming conventions because we had includes and rec calls. And later on I'm gonna have a local patterns, and patterns at module includes are gonna be our includes, and patterns at rec calls are gonna be our rec calls, but are gonna be module rec calls, and maybe we're gonna do it like that. You're gonna see in a second why. And now I just need to append to that, and I have again completely forgotten how to append to a list, but that's okay. How build modules is like the one that we are looking for, and build modules get, yeah, just like with table insert. And I basically wanna do the same here. So I want a table insert into includes, and I wanna kind of like append a include, and I'm basically gonna have a few spaces in here. And then I want to append kind of like the path to the include. Or actually the include is not going to have spaces. It's just going to be hashtag include. And then there's going to be some paths to the module. And then for the rec call, I don't know if I can press Windows V in a YouTube video, but yeah. Then we have the actual register call. So that's going to be BL2D. Let's maybe do it like that so that we don't get namespace issues at some time. And then basically what I want to have is I want to have the call from main. Where is my main file? Have I closed my main file? No, I haven't. I'm inside the main file. Oh, that's amazing. I already removed it. But it's like module manager get, and then it's register, and then it's like the type. Get.register, and then it's gonna be the type and some boilerplate code. This is kind of like the register call. The register calls are going to be different. I'm gonna show this to you in a second. We're actually gonna build them up out of multiple lines, but we're gonna tackle this like step by step so that we don't get lost in here. The include is actually a bit more interesting. Currently, you can see that the include works like that. We have the I is interface. We actually have the package name and the package name again .h. This is kind of like the include path that I need to kind of like fill up, and I need to, of course, replace these with the proper names. And this is now the interesting, is it KI or IK? I pairs. Where's the normal pairs? Pairs, it's key and value. So it's probably like IV, index and value. And it's like the value that we are interested in to generate the headers. And inside of the type, the actual type that we want to register, let's actually see how did I do the namespace conventions in the module. It's BLTD modules name. Okay, this is kind of like, this is like exactly how their class is called, but with underscores. So the name shall be here. No, it's not completely here. It's BL2D modules, and then the name with underscores needs to be, of course, replaced by the correct name. And I think we can maybe try that one out here, actually. That syntax, that should work as well. I tend to like that actually more. And then it's gsup. And how do I do my gsup? I already should have it somewhere. We already used that. String.gsup content. Yeah. But I want to have gsup for the name. So that's the gsup call that I want to call. In general, it should work like that as well. So I take the value as a kind of like class, and then I gsup on that. And then we should have the register call. Rec calls, no. Okay. And currently this is like, I think I should have this as a string. It's better to have these as a string and then call something like append. It's probably gonna work. Lua string append. Let's see. I know that this works with double dots, but is there also a Lua string class? Let's see how the string library works. Lower, upper, sub, append. No, is there no append? Okay, if there's no append, I'm actually fine of just doing this. And what I then, of course, need to do is I need to add a new line, but I'm fine with that. So adding a new line at the end is I think, good. Not quite sure. I think I can do a new line here in Lua because it's like awaiting something. Not sure of that actually, but we can try that. Let's see. And this shall now generate register modules. And if we have a application, we want to generate a modules file. And actually what we have forgotten is we actually have the out file. The out file is missing. Templates, Lua module, generate file. Where's this file? File F. It's like coming from the name and the ending. Yeah, okay, this is the full file name, but I do need to go one directory up because I am in the interesting in which path am I? It's dot slash. It's the current path. I'm just dumb. Of course, we need to generate the file, like the patterns are here, and we need to have that call in here. And actually, I think I can just get away that, but I don't need the ending here as a template. And this is now the register modules.cpp and the patterns. However, F is the out file, which is dot slash name dot ending. So okay, register modules.cpp. All right, and now I just need to call that function. I think I already tried that. And I'm gonna require the modules that I'm also linking against. Let's see, moment of truth, if this works or if it blows up. It seems to be good, and it also generated a register modules, but it... No, I'm in a template one. I don't want to go into the templates. I want to go into my source app register modules. Okay, so I have a hashtag include in here. I don't know why I have a hashtag include in here. And I have a new line. Okay. Yeah, this is basically how programming can fool you, right? First of all, of course, I don't want to have a double backslash, because a double backslash is actually going to put a backslash in here, but I actually do want to have a new line. Actually, what I want to have is like, it's going to probably convert this. I don't know if I can get system endings. Now, here you can see another copy and paste issue, so it should be something like that. And if I rerun that, this is always going to overwrite the generates file. You could now see that it looks better, right? Now we have the include, and we have the module in here. Now if I go into C++ now, this code should now actually work already, without even needing to touch anything. This should already work because it's compiled, and so it's linked in, and the module is automatically now included. So you can see that the code already works. However, I do want to have a bit of maintenance, and if you take a look at the properties and the C++ preprocessor, we might already have a list of available modules. No, we don't have it. Actually, what I want to have is I want to also have every module that is currently loaded. I want to have this as a preprocessor. So if I have a project like BL2D project, well, actually not if I have a project. If I have an application, I actually want to know which modules are available. So these are like all of my modules. Generate defines for each module, so that I basically know which modules I am linking against. This might be totally useless, actually. No, it's totally useless. We can skip that. Initially, I planned to do that, but since we are now generating this, I'm a bit concerned, because if we have multiple configurations, we might override these. We might later on also have a list of modules that we basically want to have, and then the modules can decide if they actually need linking on that certain configuration. I think for now, we're going to keep it as is. For now, keeping it as is, I think, a good idea. And now we have automatic module loading, right? We could register all modules and we print it. So register module and debug, print. And then basically what we have here is a small module demo. So we are currently quickly demonstrating how modules work. So this is kind of like our register code. This is going to be at some point as is in our code. Of course, it's going to alter. SPD log needs initialization and stuff like that. But of course, at some point, this is exactly as is. And this is producing a list of modules that have been loaded, the dummy module and the hello world. We could quickly implement one more module. We already have done that at some point to quickly just check that it works. Let's create a new folder, dmz.mod. This is just a whatever module. And dmz.mod say that we have a module, just a quickly new module, and this should now automatically generate a lot of boilerplate code for that module. If I go into reload, I should in general have already a completely functional module. If I take a look at dmz.mod, it's already implemented, and you can see that it's kind of like already there. And if I compile this now, we also should get that this module is already loaded. Yeah, now you can see dmz.mod is already loaded. Now this is build system magic. And this is why I tend to use Premake, because Premake allows you doing stuff like that. You don't need to roll your own build system or to have CMake scripts and stuff like that. I just want to create a empty folder with a Lua file in there, run my project generation, and have my module automatically integrated. And this is going to grow. We're going to also make features that modules can be disabled on Windows or Linux, and maybe configuration-based modules in the future. But it's like, this is kind of like the base code. The M source is basically handling all of that. And basically, we have already finished 2 packages. We have finished these 2 packages, and we're probably never going to touch them again. MSOS, IOC, these 2 implementations are completely done out of our common namespace. Modules are here. They're going to grow, and in general, at some point, I want to have my main code growing all as modules. We might have a bit of common utils that are completely platform independent, like containers, maybe even interlocks and stuff like that, and like all of the basic stuff probably in a util package at some point, like common utils. But in general, this is like what's going on here. All right, so this concludes today's video. Again, a bit longer, but yeah, that's how it is. In the next video, we're going to continue with initializing our application. So actually making sure that we have a win main, making sure that we have console, that SPD log is initialized, to have a few factories for getting loggers, creating loggers, automatically logging to file, and all of the magic that you need if you want to use SPD log. And also a bit of magic maybe for exceptions and boilerplate code of that, so that we have kind of like a bit of a initial bootstrap package that automatically also calls main. The idea is basically that we have a bootstrap, or it's probably going to be called boot, a project called boot, and boot is going to define like an application class. And if you are creating your own application class, then it can be automatically booted with a macro inside of your application. And that's kind of like the general idea, right? You have a boot file, and you have an application file, and we might even implement like templates. If you're creating a new application, you're going to create a new app, and you're going to get an automatic generated main and stuff like that, so that you also have a bit of boilerplate code for a application. Yeah, that's kind of like the topic of the next few videos. So thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.